Then the next detail we are looking at is that where is the definition of these simple functions or methods, or sorry, classes. So this is DigitalOut is a class. And then when you define a DigitalOut for a certain pin, you get a DigitalOut object. And that object has the methods which are defined in that class. So DigitalOut is actually an object. Pulse width modulated out is an object. DigitalIn is an object in the C++. And then where to find these definitions, so the class libraries for these. So you actually, the easiest way is that if you are in the development environment in the MbedOS compiler or in the Mbed Studio, you can just go in your program into the operating system, click on the file folder on the left to the operating system, and then open from there the classes. And then you get into the documentation through that one. But if we are not in the compiler, we can have a look on the reference. So it is, the reference is, you go to the documentation MbedOS, and then clicking there, page embed, documentation MbedOS, and then you end up into this page. And then what are we looking first is that we are looking for the drivers, input-output drivers. So from here, API reference and tutorials. And then there is a full API list here, so you can just scroll down, or you can click here and you end up in here. So there are the drivers, and then input-output drivers. And we are looking first on the digital input. So digital input in here, digital in. And then there is a definition, how it works. So there is a class reference, and then it is explained in here. And then there is typically a sample code. So the most important things there are that you have a digital input. You define it by giving a pin name, like D7 or something in here. And then your digital input.read returns the 0 or 1. So in the C++, this 0 or 1 is an integer as a variable type. And that happens to be in this microcontroller a 32-bit integer. So it takes 32 bits to store whether there is 0 or 1. And then a pin mode. So this is for the digital inputs, a pin mode. So then you can define there either pull up. So then an internal pull up resistor is used. You can define the pull down, internal pull down resistor is used. Pull none, no internal pull up down resistors are used. I think the pull none is a default. Do they say here that it's a default? Mode, pin mode, pull more information. Do they tell that what is the default? No. They don't tell that which one of these is a default. All right. But I think the default is the pull none. So you're using an external resistor in the input, typically with the switch. Then there is a digital output. The same way you define, just write here a pin name. And then you can also write there in the parentheses, when you establish the digital output, an initial value. So that when the processor is started up, what is the initial value, 0 or 1? So if the output is then on a starting when you power it up, if it is on or off. It's a good practice to define the initial value there. Then there is the write. So that's the typical, you just set the output to 0 or 1. And then later in your code, you can use that information that did I set it 0 or 1 by reading the digital output. So there is a digital out read method as well. And then there is a short format for these write and read commands. So you can define a digital in, give it the name a button, and define it is in the bin D4. And then you can define, you have a digital output, the name for that one, a variable name is an LED, and it is on the bin D30. You could write there that let dot write and so on. So like this, let dot write, and then inside the parentheses the 0 or 1. We are writing there in the let output now the value of the button. So let write in the parentheses button read. But for this, there is also this shorter format. So you can just directly write there in the code, let equals to button. It's up to you which one you use, but it's a good practice to stay on one type of writing inside a code. So if you are using this let equals to button method style, then use it all through your code. If you are using this let write and the value in the parentheses, use it all through your code. Don't mix these two writing styles. And then there are also information like something you might use in your projects. We might also use in some laboratory experiments these later. So if you need an SD memory card, for example, to store sound files or something, so you can make your microcontroller to speak. So the speech you can save as an Windows audio file format on the SD memory card and really easily play it out from the microcontroller. And then there is the network interface. So you can use either the VLAN or the Ethernet, cable Ethernet. And then you look at this reference that how to make the communication working. And then includes always a code example. Also for the file system, there is a code example on this documentation page. So you can start developing with that code example. So if we look at, for example, the, let me write it down here. Yeah. So for example, network socket UDP includes a code example for getting the Unix time from a time server. That's an easy one you can try when you first connect the Ethernet or Wi-Fi on your development board. Then you can go and test that if you get the connection to a time server. And that was in the UDP sockets. So we go into full API list and connectivity. You first set your network interface with an Ethernet. You look at this one or the Wi-Fi. When the device gets an IP address from your network, you are there in your network. And then if the outside connection out of your network works, you can try to send an UDP message. And then on this UDP socket, there is the explanation how it works, what methods there are. But easiest is that just try out with an example. So wherever you are in that you have an access to internet, this should work. So this is a good example to try out that if you have a connection into the internet. So it is calling a time server. You can also replace the time server address in here. I think this is connecting some USA government time server or something like that. But you can put there in Finland an Mittatekniikan keskus time server, or you can even put there, if you are in the HAMK in the school premises, you can put that internal network time server address if you know it. So this is where you find the information for the details of your coding.